October the 7th, 2016. This is John Stanley. This video picks up after the general overview video of the sensor that sort of shows how everything works. This video shows how to actually put in the settings in the sensor to achieve the performance that we got from the previous video. So the sensor has got a 2-digit display, which is 0 to 50. Ignore the 2 dots down here. They indicate the power level of the sensor. On the sensor, you've got 2 push buttons. You hold this one down for about 3 seconds to go into the programming mode. Then you can walk through a list of parameters and make changes. You briefly press this one, the T button, to set the threshold. So this is a value of 10. So that means that if 0 sees nothing and 50 has maximum feedback, if we see anything over with 10 right now, the output will activate and this red light will come on. And I have the output set up for normally open. So the threshold is at 10. And just a quick review here. So right now we're looking at the box. We see nothing. Well, we have a value of 3. We see the tampon. We have a value of 0 to 3. We look sideways at the tampon, we see 2. We see the leaflet, and we go up to 50. And I'll put the sensor to the side so you can see if we're looking at a dead spot, we're below the 10, but I want you to see how the red light is still staying on. That's because I have the hysteresis function programmed in this sensor, and I'll touch on that in a second. So here we come up into the leaflet region, and we see that we go right up to 50, 40, 50, so that's well above 10. Looking at an angle, no problem. So on the machine right now, we have the sensor cocked this way and this way. That may be unnecessary. I would suggest to just go ahead and point it straight in, center of the window that we'll be looking in. That way if the product is shifted or the leaflet shifted one way or the other, we're still hitting that area. And then aim this blue light. It's 2 1/4 inches. I use the same setup that's on the machine, 2 1/4 inches. Hitting anywhere on that leaflet is well above 10, which is going to be our trip point. All right, so now let's go through the parameters, and I'm going to do them in the order that they're in the manual that's produced by EMX. So the first parameter is the LED intensity level, which is denoted as U. So let's hold this down for about 3 seconds, and we see U3. So U3 is high power on the emitter. If we push the other button, we'll toggle between U1, which is low, medium, and high. The optimization I did with the sensor, I tested all of these settings, including the sensitivity on the receiver side, the hysteresis. So what I'm going to show you is what I had the best values making this work. And hands down, these settings work better than anything else. So we want the emitter to be in the high power mode. We want to shoot out as much UV light as we can. H stands for hysteresis, and this comes in handy because you can determine the hysteresis level of when the sensor cuts off. So imagine you had something briefly come through, wasn't quite aligned up right, it tripped the sensor, but then it went right back off. By having H set to a value of 8, what that means is that if I have the threshold set to 10, that's the trip point. And let's say a leaflet came in front of the sensor and it registered 40, but then it immediately dropped down to 5. Well, what would happen is the sensor would cut off and then cut back on when it came back in the field of view. By having the hysteresis set to 8, that means that the value coming back to the sensor would have to go to 2 or less before the sensor would cut off. So the hysteresis is going to work in our favor here when you have a target that can be slightly different, and with all these folds and red ink and everything, that may be something we have to contend with. So I would suggest setting the sensor to 8. So that means if you have the threshold at 10, the trip point going off is 2. If you had it set to 20, the trip point going off would be 12. You can go as high as 9, but I think we should always have 0 and 0, 1 as error. We don't see anything, so we don't want it to stick on prematurely. All right, so after the H, normally open, normally closed, I have it set for normally open. Normally open meaning that the physical contact output or the transistor circuit changes to on when it sees a leaflet, and that's fail-safe. Next is the pulse level. So this thing has a pulse stretcher built into it. You can set it to 0, which means that it's going to basically put an output signal only 100 microseconds long. And that's just not enough. So if you put in a value of 1 on this thing, you'll get 10 milliseconds of pulse stretching. I have a value of 6 plugged in here, so that's a 60 millisecond pulse stretcher. And that is needed if you're, depending on what your PLC scan time is. If your scan time is 30 milliseconds, for the PLC program, ideally the sensor output would be 60 milliseconds because you sometimes have to do a dual scan depending on where you are in the program and when you do an I/O table update. So you can change that over here by just toggling through the different values. So basically this is the response of the sensor itself, which is like 100 microseconds. So this is 10 milliseconds, 20 milliseconds, and 60 milliseconds. So I think that is, you could change this if need be, but I think that's a good starting point. But it definitely would be interesting to know what the scan time of the PLC program is that's reading this sensor. So the next function is null. This is something you should check initially. What this involves is pointing the sensor to nothing and then nulling it out by pressing and holding the T button. And what that does is it's going to say the sensor sees nothing. We're going to teach the display to read 0, 0 for nothing. So we should do this on the sensor that we're working on the machine just to get back to square one. And then after that, you probably would not have to do that ever again. All right, and the last thing is we already talked about the power level coming from the emitter. Well, there is a receiver also, and there's a gain setting in here for the receiver. And there's 2 values, 1 times, and the 2 represents 10 times. So this is 10 times more sensitive on the receiver than the ×1 setting. This does not work that well because you have too much gain coming back from your targets and you get false good signals. So just like with any sensor, you got to find the right settings for it. And so I've played with every permutation that you can do on this sensor, and what I'm showing you in this video is the optimal settings. So we want to change this back to R1, and then after that you would then scroll back through the whole menu again. So that's all the parameters to come out of this mode. You hold this down for about 3 seconds, you see the display go back to 0, 0. So now we're back to the inspection mode. This sensor has a teach function built into it. So you can point the sensor, push a button, hold it, the display flashes, and it teaches itself. Don't use it. Just adjust the threshold wherever you want it to be. Get your sensor set up on your target, see what kind of value you're getting back. If you think that, oh, okay, looks like 40 is a good value, I'm seeing that just about most of the time, then leave the threshold set to 10, like I have it set here. Anything above 10 is going to make the sensor come on. The hysteresis set at 8 is going to keep it from cutting off, even if that trigger now goes lower than 10. So that sensor will have to go all the way back to seeing nothing before the output will cut off. So it acts like a latch. I think if you set the sensor up like this, it should work. If it does not work, we should change the sensor to a new model. And this is the same model number. What I mean to say is a new sensor. The UV emitter in this sensor has a lifespan of 11 years, and we don't know how long this sensor's been on the machine. So it could be at the point where the sensor is about ready to die, or it's not performing like it's supposed to, or the parameters don't do what they used to do before. So if you put these values in and it doesn't work, let's just stop right there and put in a new sensor and try it with the values that I have in this video.